Hello, my name is Yura, and my project is about constructing surfaces of proteins. Here you can see a classical cartoon view of a protein, and two of surfaces I implemented into Wolfram language. This problem of implementing a surface, of building a surface, is relevant because, for example, in docking, it sometimes can be very computationally expensive to use classical molecular dynamics approach, but using surface proteins can speed up things drastically. So here what you are seeing is Wolfram community post, and the link will be in the description. Here is some introduction, information about surfaces I implemented. All articles are cited, so you can go even into more details. But here's my project, one-liner import. And then we can pick a sample protein, download it from a protein data bank, see how it looks in a classical cartoon way, and then see how solvent accessible surface of a protein looks like. And well, it looks fine, but with one exception, there are no hydrogens, and that's not a coincidence because, well, usually PDBs from PDB protein data bank lack hydrogens, and now there is a way to fix it in a Wolfram language. It's a function in my package. And so we can proteinate our downloaded protein with my function and draw it again. And here is, well, we hope more or less how it would look like in the real world. Also, there are a few additional parameters you can play with, but we don't have time. So let's move on to the second type of surfaces, solvent excluded surface. In contrast with the previous case, here we don't only have a 3D picture of the surface, but we have the full mathematical representation, by which I mean the mesh, a set of triangles, a set of vertices the mesh is built on, and indices which say how you can build a mesh from given vertices. Again, there are a few parameters you can play with, and I mean you literally can play with them because everything is published. But we don't have time, so moving on to the real applications. For example, docking, I said about, is the point is that, for example, there is an article in which authors used convolutional neural networks and surfaces of proteins to speed up docking process, and we can say they succeeded. Article is again cited, so you can read it. Finally, all source code is published on GitHub, so you can see how everything works for yourself. Thank you.